All right, so today we're looking at 11.1 graphing. Once again, this just was another class notes. That class was 5.1, but graphing is the same no matter what math class you're in. We're looking at 11.1 for us, and it's graphing, and it starts off with the Cartesian coordinate plane, in which we have our horizontal axis, which is our x-axis, vertical axis, which is our y-axis. Where they intersect is our origin. The coordinates of our origin is 0, 0. Everything to the right of your origin is positive. Everything to the left of your origin is negative. Below your origin is positive. Below your origin is negative. Above your origin is positive. Split up into 4 quadrants, going counterclockwise, quadrant 1, 2, 3, and 4. To get into quadrant 1, you have to do 2 positive moves. Quadrant 2, negative, then positive. Quadrant 3, 2 negatives. And then to get into quadrant 4, you have to go positive and then negative. So I'll give you a chance to write that out before we scroll up. All right. Okay, so we're going to graph what we call ordered pairs. It's called ordered pairs because the order matters. Your x comes first, then your y. So your horizontal move is first, then your y move. You think about x comes before y in your alphabet. You walk to the elevator, then go down. You run, then jump. Whichever way that helps you remember is always your horizontal move first, then it's your vertical move. All right, so let me erase these so we can walk through it. All right, so let's graph these 6 points. You always start at your origin. So looking at 2, 5, I go to my origin, and because it's a positive 2, I go right 2, then up 5. So that puts me in quadrant 1. 2 positive numbers, 2 positive moves put me in quadrant 1. For negative 1, negative 3, I go back to my origin, go to the left 1, down 3. And that puts me in quadrant 3. So 2 negative numbers or 2 negative moves put me in quadrant 3. For the third one, to the left 4, up 2. That puts me in quadrant 2. Then go back to your origin, go to the right 1, down 5. And that puts you in quadrant 4. So before we go any further, problems with those 4 points. All right. So for the fifth one, notice it's 3, 0. So we go to the right 3, but we do not move off of that x-axis because y is 0. So it is just sitting on the x-axis. And then similarly, 0, 3, you don't move left or right because x is 0, but then you go up 3. And that's sitting on the y-axis. All right, any questions? All right. So solutions. A solution would just be an ordered pair that when you plug it into the equation is going to be true. All right. So an example is this one right here. We have 4x minus 3y equal to negative 2. And they give us this ordered pair of 1, 2. Don't forget your first component is always x, second is y. So we plug them in accordingly for x and y. So 1 for x, 2 for y. So that's 4 times 1 minus 3 times 2. 4 times 1 is 4, 3 times 2 is 6. So we have 4 minus 6, which is negative 2. And so that means it is a solution. All right. So here, just pointing out the fact that there are infinitely many solutions to a linear equation. And so if you're talking about the graph of that line, each point that's on that line represents a solution. So every single point that's on the line, when you do your graph, represents a solution for that equation. So when you look at what we had here, the ordered pair 1, 2 is going to be on this line after you graph it. So here, just did another example. This time, give you one equation to try, and then they give you two different ordered pairs to plug into that one equation. So I took 2, 3, plugged it in for x and y, and then did the same thing for 3, 4 down here on the right. So for the first one, plugging in 2, 3, that means 2 is x, y is 3. So that's what we have going on right here. So that's 3 equal to 3 times 2 minus 5. 3 times 2 is 6, minus 5 is 1. So you see we have 3 equal to 1, which is not true. And that means we do not have a solution. Or in other words, 2, 3 is not a solution of y equal to 3x minus 5. Then over here, we do the same thing. Plug in 4 for y, 3 for x. 3 times 3 is 9. 9 minus 5 is 4, so 4 is equal to 4. And since that works out, it is a solution. Any questions? All right. So graphing linear equations. Erase this. So for us, 11.1 and 11.2 is there. And if I'm not mistaken, we're doing 2, 3, and 6. Let me make sure before I make sure intercepts and slopes aren't in the same section. Oh, okay, that's in 2. This is 11.2. It's 11.3. All right, so when it comes to graphing our linear equations, linear because the equations will graph or produce a line. So that's called linear equations. So 11.1, 11.2 pretty much sums up that first method, the XY chart. You create an XY chart. 11.2 also has intercepts in it. And then 11.3 talks about your slopes. All right. So let's at least look at the first method today. We might be able to do intercepts as well. So let me erase this stuff. All right. So first method, create an XY chart. So you would choose the X values that you plug in. All right. It doesn't matter what X values you choose. We'll talk about Y in a second, but it doesn't matter what X values you choose. Just remember, whatever you choose, you're going to have to graph it. So I chose -1, 0, and 1. If you choose 1, 50, and 1 million, that's fine. Just remember, you have to graph that. So I chose -1, 0, and 1. When in Connect Math, I believe you only graph 2 points. So I have a habit of doing 3 points. But I believe in Connect Math, all you can do is 2 points as far as plotting and then connect your lines. So what this says is that when I plug in X, what's the corresponding Y value? And that's what you want to find out. When X is whatever number, in other words, when X is -1, what is Y? So you plug in -1. 2 times -1 is -2 plus 1. -2 plus 1 is -1. So it just so happens here when X is -1, Y is -1. Of course, that would not always be the case. But you do the same thing for the other two values. Plug in 0. 0 is always an easy value to use. 2 times 0 is 0 plus 1 will be 1. And then plug in +1. 2 times 1 is 2 plus 1, which is 3. So we have our 3 points. Before we graph, any questions on how we got those 3 points? So you choose the X values, plug them in to find the corresponding Y values for the X values that you chose. All right, so we good. Very good. So you grab those 3 points. You see I have that right here. If you look at -1, -1, so you go to your origin, go to the left one, down one. That'll be this point down here. 0, 1, go nowhere for X, and nowhere to the left or right as far as X is concerned, but go up 1. It's right here. Then right 1 up 3. would be right here, and that would be our line. All right. So remember I said that it didn't matter what points you chose. Just remember that as long as you choose, whatever you choose, you got the graph. If I were to choose something way over here, let's say positive 20, that will give me a point that's way up here that will connect to this line. If I were to choose negative 100, be way over there, it will give me a point that's way down here that will still connect to this line. So no matter what you choose, you will still get this line. It's just that, like I said, you have to have the ability to graph whatever it is that you're choosing. All right, any questions on that? All right, any questions? All right, so let's look at another one. I'm going to erase this, but then I'll put it back. I just want to make sure we're clear on what was here. All right, so let's say if we have, I didn't even do that, but anyway. Let's say if we have y equal to negative 3/5 x plus 2 as our equation. So now you want to be strategic in what you choose for x in this case because we have a fraction involved. You chose negative 1, 0, and 1. The 0 will take care of itself because 0 times anything is just 0. But you'll have a 1 in there that will still produce another fraction. And you don't want to have to graph a fraction or decimal if you don't have to. So what we're going to do is choose values that would actually cancel out the fact that we have a fraction involved. All right, so it's all going to be based on the denominator. So we're going to choose multiples of that denominator. In other words, values that the denominator can divide into evenly. All right, so when we look at this 5, I would choose values like 5, 10, 15, 20, something that the 5 can divide into. If I had 7, I would choose 7, 14, 21, 28, something that the 7 can divide into. Same thing as if I had 11. I would choose values that the 11 could divide into evenly. So I chose negative 5, 0, and 5. Right? So if you look at the first one, if we plug in negative 5, and you see that right in the negative 5 is 5 over 1, you can just multiply across, and that'll be 15 over 5. 15 divided by 5 will be 3. 3 plus 2 is 5. So when y is negative 5, x is 5. Do the same thing for 0. It's right here. 3/5 times 0 is 0. And 0 plus 2 is 2. And the last one, plugging in positive 5. 5 times 3 is 15, so it's negative 15 over 5 plus 2. Then negative 3 plus 2 is negative 1. Any questions? And then you graph those 3 points but that was a -1. Grab those 3 points, and then you'll get your line. All right, so we can look at intercepts before we leave today. Questions on what we did here. You choose your x values, plug them in, find the corresponding y values, then you can grab those points. And that's all there is to the first method, creating an XY chart. All right. Next method, last thing we'll talk about today is your intercepts. All right. So your x-intercept is where the graph intercepts across the x-axis. And a key characteristic of all x-intercepts is that y is always 0. And for your y-intercept is where the graph crosses the intercepts or intercepts the y-axis. And the key characteristic of all y-intercepts, is that x is always 0. I'll give you a chance to write that. All right. Hold up, everybody good? All right, let me erase some of this so we can walk through it. All right, so we have 2x plus 3y equal to 12. We want to find our x-intercepts, y-intercepts, and we want to graph using our intercepts. Basically, we're going to find our x-intercept, find our y-intercept. Doesn't matter which one you find first, as long as you stay consistent in what you're doing. And then we'll be able to graph those 2 points, giving us our line. So I decided to find my x-intercept first. Remember, I mentioned that if you want to look for it or find your x-intercept, the first thing you have to do is let y be equal to 0. So that's what I did here. So we have 3 times 0, 2x plus 3 times 0 equal to 12. 3 times 0 is 0, so that leaves us with 2x equal to 12. Divide by 2, x is equal to 6. So the ordered pair is 6, 0 for your x-intercept. Then you'll do the opposite for your y-intercept. For your y-intercept, you let your x be equal to 0. 2 times 0 is 0. That leaves you with 3y equal to 12. Then divide by 3. 3's cancel. Y is equal to 4. Now be careful here, your ordered pair. Remember, x always comes before y, so that's going to be 0, 4. All right. Any problems? Any problems? Graph those 2 points, 0, 4, and 6, 0. And that will be the line. All right. Let's do that one more time to make sure we're good. Once again, erasing so we can walk through it. All right, so we have 5x minus 4y equal to 20 this time. Once again, we're going to find x-intercept, find a y-intercept. Let y be equal to 0 for the first one if you're trying to find your x-intercept. So that's what we did here. 5x minus 4 times 0 is 0, and that's equal to 20. So that leaves us with 5x equal to 20. Then from there, divide both sides by 5. 5's canceled, and that's 4. X equal to 4. Ordered pair is 4, 0. Then this next one, I'll let x be equal to 0. So 5 times 0, 0, leaving me with negative 4y equal to 20. So make sure you don't lose that negative or that minus sign is sitting in front of 4y. Divide by negative 4, and that'll be negative 5. That's an ordered pair. I mean, for my y, and that's an ordered pair. That'll be 0, negative 5. Any questions? All right. Grab those 2 points, and that'll be your line. See, just talk about horizontal. Yeah, I can go and do that. Any questions before we look at horizontal and vertical lines, then close it out? Okay, next thing doesn't call for any calculation. So horizontal lines. Notice each one of our equations up to this point had x and y involved. So you look at right here, x and y is involved in the equation. If you come to an equation that just has y, you don't need any type of calculation. All you need to do is recognize that y is equal to that number. So in this case, we have y is equal to 5. So no matter what x is, y is always going to be 5. So I chose negative 1, 0, and 1, and y was 5 in each case. And what that does is when you graph it, it'll give you a horizontal line at 5. All right. So now just re-emphasizing that x can be anything. But y is always going to be 5. And that'll give you a horizontal line at 5. And then for, let's say if all you see is x equal to a number, this means that x will be that number always, and y can be anything. All right. So x is always -2, and y can be anything, and that will give you a vertical line. So whenever you have y equal to a number that's a horizontal line, x being equal to a number will be a vertical line, and at whatever number they give you. All right. Questions? Any questions? All right. So that's it for 11.1 and 11.2, just graphing. 11.3, we'll look at next class, which is slopes. And then we'll go from there. Any questions or concerns before we close out? All right. Well, you guys have a good one. Be safe. And then I'll see you guys next class. See you on Wednesday. All right, thank you.